GM. Good morning, guys. Basically, that's the meaning of GM. Good morning to you everywhere you are in the world and whatever time you are currently in the world. So we'll start our intro to Cairo today. An intro to Cairo, we are not actually taking Egyptian air to Cairo. We are taking a plane to Cairo Virtual Machine land. And we are going to be learning a lot about Cairo. I want it to be methodical, meaning that I have learning objectives so that by the end of this class, we have 3 or 4 things to know that, okay, we have mastered this or we have been introduced to this science. The first one is Cairo itself. The Cairo programming language, you need to be able to say a few things about Cairo in 2 or 3 minutes without looking at any material. The second one is setting up your local development environments. So if you are on Mac, you should be able to set up your environment. If you are on Windows, you should be able to set up your environment. And the third one is getting familiar with basic syntaxes in Cairo. So you learn variables and you learn data types. And on the long run, the last of the objectives is that you will be introduced to Starkling. Starkling is like a game. But in this particular game, you will be requested to solve programming puzzles, especially Cairo puzzles. So if you're able to solve them, you move on to the next stage. So these are the 4 learning objectives that I actually want to achieve today. So meaning by the end of this class, we should be able to do all of these things. So Cairo programming, I love my class to be interactive. And I am very sure you have been introduced to it in the previous class, but now we are going to retake it. Cairo programming is a stack-based language written for verifiability and provability. If you are familiar with zero knowledge, you know that the essence is for you to be able to write programs that are replicable without actually running computation of the programs. And that is the essence of Cairo. Cairo is meant for stack-based zero knowledge. I'm very sure a lot of you must have heard about stack, snack kind of ZK, right? So Cairo is meant to write program for stack-based ZK. So Cairo is a programming language developed for provable programs. So it is a Turing-complete language. Computer science students in the class, what is a Turing-complete? When they say language is Turing-complete, what does it mean? It doesn't execute to infinity. And it means that it can be used to program a complete software. So it doesn't need any other addendum to actually be able to write provable software. Yeah, to write software. So Cairo is a general purpose language too. If you are a cryptographer and you are writing ZK-based zero knowledge, and you are writing stack-based zero knowledge rather, you need to master Cairo. And if you are also going to be basically StackNet dark developer, you also need to master Cairo because Cairo is also the smart contract language for StackNet. In your previous class, rather, I believe you must have known the relationship between Stackware, StackNet, and the rest of them. So meaning that Stackware, who are also the brain behind Cairo, made sure that Cairo is also meant for writing provable languages for your ZK and also writing smart contracts language for StackNet. Provable computation. When they say something is provable computation, who can give me an idea of what that means? What does the provable computation mean? Anybody? Any idea? A provable computation just means that once you write a function, this function has constraints. You can't go beyond certain level. Let's say function add a plus b, and then in the body of the function, you return what is known as function add a and b. In the body of the function, you return what is known as ab. So this is particularly for a program. So this particular program now, when they say provable and provable program, once this particular function has run completely or successfully on your PC, the other person will not need to run this. They only need to be able to prove that when you supply A and B, the response, which is A plus B, is going to be provable without actually knowing the argument that you supply to this particular function. So, for example, now, I have a mini computer that cannot run a particular program, but you have it. You have that computer that can run it. I give you this particular function to run for me. You run it and give me the outputs of that particular function. So when that happens, I do not need to run that function on my computer anymore. All I only need to do is to take the output you give to me, run it through certain parameters, and if it comes out successfully, it means you have actually done the computation. Are you following? Is that clear? It is not clear. It is giving me the vibe of those of you at the back. What did you say? Yes, sir. When you said what? Yes, sir. Present, sir. Absent or present? Present, sir. So I wanted to show you what a provable language program is actually. But before I dive into that, one of the learning of is that your local environment, your local development environment. You already set up local development environment for Cairo. What is it up to everybody? Yeah, definitely. Then we can proceed. Then, so let's say we want to write a provable language program, right? We have Scab. To start a new project, what do we do? Scab new provable project. In this situation, because we are writing a Cairo program, not a StackNet-based smart contract, we are going to choose Cairo test. CD, provable projects, and commit. For you to be able to replicate this, we are going to take an example from the Cairo book itself, proving that a number is prime. Bonus question. Every of your Cairo-based project needs a particular function before it can run. What function is that? Main function. The main function. So this particular function is meant to test whether a number is what? Is prime or not. So if you look at the body of the code, we are giving it constraints. This is what it means, constraint in ZK, in zero knowledge proofing, right? So if this number is this particular thing, return. So we are looking for ways to get the prime number. To be able to write provable language, provable programs with Cairo, there are certain setups you need to do. So you need a Cairo test dependency. What is cap.toml? What can you relate cap.toml to? Package.json. So you need target executable. What do we call this in Cairo? Manifest. All right. So this is basically showing you how to write a provable ZK stack program. When you are doing zero knowledge, there are about 3 participants: the prover, the proof, and the validator, right? So the prover is actually the one that runs the program. So once they run the particular program, they generate proof of execution. It is that proof of execution that is sent to the validator to validate that this is actually correct. So Cairo is actually a language that is used to write this provable program that a proof can be generated from. Cairo, or let's say Stacknet or Stackbase, use the efficiency of Stool. Stool is like it's a proving machine to prove a particular ZK-based program that you have written. All right. I won't dive into the body of the function, but the function is basically checking if the number is what? Is prime. We test if our program is actually prime, we supply an argument. The argument here is number 17. So we want to know whether 17 is a prime number or not. So all of this detour is to show you that Cairo is not only meant to be used for writing smart contracts, it is also meant to be used for writing provable programs. And that is basically what it is meant for. Stackware started with the technology of ZK before they now extended to writing smart contracts-based blockchain, which is Stacknet. So Cairo initially is meant to be used for writing ZK. Are you following? And this is how it is done. So once you see 1, it means that this particular function is what? 0 and 1 in Boolean value. What does 0 represent? You said? 0 represent what? And then any other number represent what? So meaning that 17, is 17 a prime number? You said? It's only divided by 1 and itself. And we are getting 1. Is that accurate? Let's try another number that is prime number. Then we'll determine whether 0 is actually true or false. What other number is a prime number? 7. So what does 1 represent here now? What number isn't a prime? 6, so here, our output means that 0 is what? Is false, and 1 is true, right? So we have this program now, we have run the computation. How do we now tell somebody else that we have done this computation without telling them to run this computation again? We generate what is known as proof. So let's generate the proof. When we actually executed this particular program, there are some things that are actually written into our target folder. And here you will see execute. We have execution 1, execution 2, execution 3. Those are the 3 computations we ran. The first one, 17, the second one, 7, and the third one, 6. So we want to now generate proof for our 17 execution. That's why we are adding this flag, execution ID 1. We have our proof now. So if we are actually now sending this across the world, this is the only thing we need to send to the other person as a proof of our execution, this JSON file, proof.json. So when it gets to their end, all they need to do is actually verify. Did you notice anything here? When we are trying to verify, it is like fast. Is it starting to make, are you starting to connect the fact of how Starknet comes to be a very fast blockchain now, right? Do you know that on Ethereum now, every validator needs to actually run the same computation, right? So, but on Starknet, only once the scroll generates the proof, all the other validators only run what? The proof. So they do not need high machine configuration. They do not need fast internet, because all what they are trying to do is that the constraints of this particular program is an addition or a prime. We are defining now it's a prime, right? So once we already know the concept is that it's a prime. Number one, we don't want to know the kind of argument it is given into it. Remember, when we were trying to prove, we did not have 17. Are you following? We are trying to prove not add 17. We don't need to know what argument has been used to actually run this particular program. That's one of the things that make your transaction secure on Starknet too, because they do not need to replay all of the transactions that Stuo generated a proof from. They only need to run the proof that Stuo generated. The constraint of a transaction on Starknet, you must have learned about it before. The characteristics of a transaction on Starknet has been written for Stuo to validate. Are you following? Once Stuo can generate a proof for a transaction, it means that transaction is what? Valid. So the essence of this detour is to show you that Cairo is a language basically for writing zero knowledge proofs. Are you following? So it's as simple as that. You can go on, write your own computation, send the proof to the person beside you, tell them to run it on their system, and as long as they have that JSON and they have the target file where the scab is targeting. So it is basically to generate stack mathematical proof of computational integrity. It enables trustless verification of program execution. Because now we don't need to trust. All you need to do is what? Give us proof. You cannot tell us that you have done the computation just by telling us, then we accept that you have done the computation. We need proof. So once you generate a proof of your computation, we will be able to verify it by actually running the verifier. Are you following? It is ideal for computation requiring computational trust, like blockchain scaling solutions. We really want to know if you have done the transaction. You can't just tell us that you have added a transaction. Have you done the transaction? Yes. Where is the proof? Give us the proof. One of the features of Cairo is safety. Cairo is inspired by Rust. Rust is what? A statically typed language, meaning that at compile time, every type in your program, in your software, or your program, rather, is known to the compiler. There's no assumption here. So every line is known to the compiler ahead. And it saves us error of what? Runtime. So if it doesn't compile, your code will not work in runtime. In fact, you don't need to bother. Once it doesn't compile, you know that there's an error in your code. So it saves you a headache of having to debug in runtime. Instead, at compile time, all of your code needs to be correct according to the constraint of that particular compiler. So it's a linear type system. The values are used exactly once. Borrowing, ownership. A lot of you are familiar with Rust, right? Rust. You will. That sounds good. So it is optimized for generating stack proof. Look at what we just did now. We generated a proof, but this proof is what? A stack-based proof. It has the parallel proof generation ability. So what's the language feature of Cairo? Rust inspired. Almost all of your syntaxes are related to Rust. So if you are already familiar with Cairo, you are almost there with Rust. Cairo has a limited scope, majorly for proof generation and Starknet-based smart contracts. But Rust has an indefinite application. So you see, it is not that you are there yet, but if you have mastered Cairo, you are almost there with Rust. It has first-class support for algebraic data types, integer, unsigned integers, pattern matching and destructuring. We'll get to this pattern matching and destructuring when we get to Starklings. We'll do Starklings before we end this class. Zero cost abstraction. This is one of my best features of Cairo and Rust. Zero cost abstraction, meaning that there are some abstractions, especially when it comes to, what do we call this in Rust again? When it comes to, let me show you an example. Somebody will remember what I'm talking about. When you want to start writing a Starknet contract and you have an external attribute, hash Starknet space contracts. Macro, yes. So a macro is actually used to abstract away a lot of code. When you have a macro, that line, that single line you are seeing in your code is not a single line. When it is compiling, it is going to expand to a number of code. So once you see you are writing a Starklings smart contract, this is a macro attribute. This thing you are seeing as hashed Starklings smart contract, right? Starklings contract. This is not what it is compiling. It is expanding. It is capturing everything under this particular macro, right? From where you open the first curly braces to where you end the curly braces. Everything inside it is going to be expanded and wrapped inside another code. Because it is that particular code that Starknet VM understands. Are you following? So whenever you see any attributes, these attributes are going to be what? They are going to be expanding. So zero cost abstraction here means that even if these things are going to be compiled to a larger code, it doesn't actually cost anything. You only need to be able to do this when you need them. You don't pay extra for using attributes. There's no extra computation for using attributes. Because at compile time, it tells you exactly what you are going to be running. Powerful macro system. In Cairo, you can't make your own macro in Cairo, but you can make your macro in Rust. So if you want to, but there's something relating to macro too. In Cairo, you have components. But in Rust, you can actually have a macro that matches certain regular expressions. So at compile time, all those regular expressions is going to now transpile to the exact code that you are supposed to write. Any question? Let's make this interactive. Is there any question currently? What's the primary language of smart contract on Starknet? Can you write smart contract with Python on Starknet? It has built-in support for blockchain primitives. It needs to install SCAB differently, Cairo language server differently, Starknet Foundry differently. But now there is a particular package that allows you to install all of this in a single local, on your local machine. You go to your root, then you do copy this line and paste it. Stack up, that's all. Stack up, we install all the two chains needed to start writing Cairo language and Cairo smart contracts. Are you following? And this is particularly if you are on Linux or Mac. But if you are on, oh, sent that to me from WhatsApp. If you are on Windows people, I love them. To be honest, right? People feel like I can't code, I cannot start writing code because I'm using Windows. That's a nonsense excuse. Just install WSL. Windows server, Windows subsystem for Linux. Once you install that, you'll be able to do the same thing that a Linux user will be doing, right? And if you want to know if this particular code command runs correctly, you go and run your SCAR version. Once you see this output, it means that you have a working local development environment on your machine. From here onwards, you need to start chewing and eating Cairo code. Are you following? So do you know how to set up your local development environment? If you are using we'll share a link from now. we have covered two of our learning objectives. What is Cairo and setting up a local development environment. From here, we move to understanding Cairo syntaxes, Cairo concepts, and the rest. We will write code, but that will be later on. One of the key concepts or key feature of writing a Cairo language is known as mutability. Remember, when we were talking earlier on, we said linear system types ensures values are used exactly once, meaning that you should be able to use a type declared once unless you specifically state that it can be used more than once. Mutability here means that look at this line. Let mute I equals to 3. Ordinarily, if you do not add this keyword mute, M-U-T, in this particular situation, this code will fail. What happened here? Error. Reference argument must be a mutable variable, meaning that we cannot mutate 3, the value of I, because we did not specifically. Ordinarily, every variable is what? Immutable. Every variable declared in Cairo is immutable. Otherwise, when you specify that you want it to be what? Mutable. So Cairo used an immutable memory model. Once a memory cell is written to, it can't be overwritten, but only read from it. I will explain that. Even when you are making a variable mutable, you are not writing to the same cell. You are writing to another memory cell. Are you following? Let S equals to 1. That is the this particular memory cell. But when you make it a mutable variable, and now say S equals to 4. This 4, this value is not overwriting what is here. Instead, it moves to another memory cell. Are you following? This is exactly what is happening. Under the architecture does not allow you to overwrite memory cells. And that's one of the reasons why you can actually prove that a computation has not been touched. And it saves you a lot of headaches. Variable are immutable by default. Once it is assigned, it cannot be changed unless you make it immutable with the mute keyword. Under the hood, when you modify a mutable variable, Cairo creates a new variable with the same name but different value. Is that correlating to what I've just shown you now? Yes, sir. Are you linking the two now? So even when you mutate a particular variable, it doesn't override the previous memory cell. It just creates another variable with the same name on another cell. In your Rust class, they call it pointers. This variable is pointing to this particular memory slot. That one is pointing to that particular memory slot. You understand? Both the variable x, initial value, is pointing to another slot, while the mutated variable is pointing towards a different slot entirely. Variables are declared in Cairo with the let keyword. Let keyword. You can't just go and say, I beg, mute I. Abeg, mute I is equal to this. Pardon me. Or any of this, any other word you can use. Let me go. It will never take that. So it is what? Let keyword that you use to declare a variable. When you declare a variable in Cairo, it must be initialized. You can't just go and say let mute I, blah, 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 or let I. You know, this is pardonable in JavaScript, right? It's also pardonable in TypeScript too, right? But in Cairo, you cannot just declare without initializing a value. Even if you are not ready to initialize, you can set it to what? Let I equals to 0. We'll get here currently. There's something I want to tell you here. You see this let I equals to 0, right? It is not like JavaScript where you declare this and then it can be anything. Here, the compiler is actually factoring in that this I, the value we set to it is what? Is an integer. So it is automatically getting the type of I. But if the value is not known, it will tell us to do what? To annotate, to specifically annotate the type of the variable we are actually setting. Let is not the only one you can use to declare a variable. We also have what is known as const. Unlike let that pardons us, when we do not annotate a variable, const will never pardon us. Let's say const I or const money equals to plenty. Right? Const money equals to plenty. Can you see all this squiggly line? It is telling us, no, we won't allow you go unless you annotate this particular type. The squiggly line has disappeared, right? But if we do that for let's, it allows us. Yeah, I know what you want to do. Are you following? So we talked about the constant and why you need to annotate a constant variable declaration. There's also this part of variable declaration known as shadowing, meaning that you can declare a variable twice, even when you do not specifically want to mutate it. For example, here, you can say let I equals to 0, and here say let I equals to 10. Can you see that we're able to change the value of I without any complaint from the compiler? That is possible because we use the let keyword twice. If we want to reassign another value to this I without using let, it is going to tell us there's an error. Are you following? So let's use twice, meaning that you are shadowing the first variable declaration in the subsequent declaration. Meanwhile, once you do this, your first value is what? Is invalid. From this line, 22, downward, your x is what? 10. Are you following?
Does that mean like memory cell now? That particular memory cell is still
that memory cell is invalid. That first memory cell is invalid now. Okay. The new memory cell now is that this is just how it is. X equals to 0 is pointing to this cell. Okay. X equals to 10 is pointing to this cell. Are you following? Okay. So if you want to access the value of S, you never go and reach the value stored in this cell anymore. It is going to be this one. Advanced memory explanation means it protects against memory leakage. Meaning somebody cannot just write a program to read the value of that invalid memory cell. You are to use lets, especially when you are in function variable declaration. Are you following? Let me show you what I'm talking about. I cannot come here and say, let's I equals to 10. Are you following? What's happening here? Squiggly line. But in function, I can say let n equals to 32. Are you following? But in outside of function, especially when it comes to StackNet contracts, outside of the implementation, you have the ability to use your const to declare values that you'll be reusing throughout your smart contracts. For example, you have protocol fee for your project. The protocol fee is stable, right? Use that and declare it with const. Everywhere in your code where you need to use the protocol fee value, you use that particular const. Sorry, let me give you an example here too. Look at this. We declared an error message with const, right? Everywhere I import this, I bring this particular error module into scope, I can easily use this empty recipient without needing to actually write the whole string. Is that got it? So it is majorly used for reusable values in your code, values that are beyond a particular function. I already mentioned the variable shadowing, right? One thing we also learn in the course of doing our Starkling is this into and try into. Into, they are just like, who can tell us a little about type conversion? Changing one data type to another. So this is exactly what into and try into is doing when it comes to Cairo. Whenever you know that this conversion can never fail, you are very sure. For example, when you are converting the value of unit 256 to unit 8, when you are doing that, you are very sure, right, that your conversion can never fail, right? Right? I'm setting you up. Huh? So the largest number of raised to power 256 minus 1. The largest number of this can fit into raised to power 8 minus 1, right? No. Can it? No. But you are sure that it can never fail. No. So if I'm trying to convert a number that is the largest number, the U256 dot max, and I'm trying to convert it into U8. So in that situation, when you know that it might fail, even though I have a U256 type, but it is 8, the value is 8. I'm the one that knows the value. The compiler doesn't know the value. You understand? The compiler will tell me that what you are converting to, there's tendency that is going to fail if you are actually using the maximum possible value of that particular data type. So in that situation, we use what is known as try into. Don't worry, all this implementation under the hood, we'll still talk about it. Then if you are very sure that it can never fail, switch that around, vice versa. The largest number of unit 8 will definitely fit into 256. Then use it, you are very sure. We've not gone into data type, but we already talked about data type. Now let's talk about data types. The primary data type and every of your program mostly is going to actually compile to what is known as effect 252. Effect is a feed element. And this feed element is the native type in Cairo. So in context, it is an integer or in the range of 0 less than or equals to x and less than equals to less than p, where p is a very large prime number, currently equal to, nah, this is not correct. Here is the number we are looking for. So the largest, the prime number that is currently equals to 2 raised to power 251 plus this particular mathematical expression. This is the P. This is what P represents. So basically, your function, your native type in Cairo is what? Effect 252. So it can be a decimal literal, it can be an hexadecimal literal. We also have an integer. We have fixed size integer from U8 to U256. What's the difference between Cairo and Solidity in this aspect? There is only one integer accepted in Cairo, which is what? The unsigned integer. Meanwhile, in Solidity, you can have what? A signed integer. Meaning that you cannot use a negative expression in Cairo. Like the value of x is -1. A negative value. Let's say let x equals to, let I equals to -10. This value will definitely not compile because it doesn't support negative value. Are you following this PD line? We can't have a negative value in Cairo. So it only supports numbers from U8 to U256. As I mentioned earlier here, U8 is basically 2 raised to power 8 minus 1 up to 256. Minus 1. Now, there is something a lot of people miss out when it comes to Cairo. When you use U256, the basic data type is 252. Meaning that it was 252 bits. The maximum bits in Cairo is 252. So whenever you declare a value with U256, you are already going beyond the band of what? 252. In that situation, you need 2 slots. Whenever you declare a variable here, currently, these are slots, right? You declare a variable that is in between 252 bits, right? It gets stored here. But whenever you declare a variable that is what? 256, it combines 2 slots, 2 feed elements. 252 is the maximum. So it needs 4 more bits So it looks for it in the next slot. We have two slots created for any value that slots. So take note of this when you are doing computation, you are writing smart contracts. And you definitely know that your value will never be 256 maximum. The U 256 dot max, which is the largest number obtainable from U 256. Once you are very sure, do you know what this number? Somebody should do the calculation for us. 2 raised to the power 256 minus 1. It's a very large number. Once you know that you are not using the maximum value, you already know what you are looking for. For example, you want to declare your protocol fee. Let me go back to that again. You say 2.5%. You already know that is not U256 maximum, right? What type of data type do you use? The smallest data type, that's U8. So it saves you a lot of computation. Instead of the program now looking for two feed elements, you save your 256 data type. We have Boolean, true or false. It's a type in Cairo. So if you want to determine whether a particular variable is what of Boolean value, you use the bool data type annotation. We have the unit type. Unit type is basically no type. Yes. A function without return is a unit type. Are you following? A function without any return is a unit type. We have tuples. We have tuples too. This is actually like an array, but instead of identical data type, you can store different data type in a tuple. Are you following? Look at pair. Pair has actually been annotated with two data types. The first one is a U32 and then a bool. And the value 42 and 3. There is string literals. Here is a string literal. Any single quotes you see in string literal is what? Any single quote you see in Cairo code is what? A string literal. And there are actually constraints on a string literal. It is also called short string in Cairo. It can only take 31 characters. 31 characters. Anything above 31 characters is no longer a short string. If you need a string that is more than 31 characters, you use what is known as what? Byte array. So a byte array instead is what? Double quotes. This is a type for handling longer string. And this is a much longer string that can exceed 31 characters. We have arrays and custom structs for complex data structure. In the next class, you are definitely going to be learning about complex data types. So it's beyond the scope of this particular class. But know perfectly well that an array is just like a tuple, but instead it's only identical types that can fit into an array. Are you following? Let me give you an example of that. This is an array of what? 5 elements. And the type of what? U64. If I want to do this on my machine, Will this work? Why won't it work? Perfect. I have mixed up the types that the array is expecting. The array is expecting a type of U64. But here I've added what? A short string. So if I try to compile, the compiler will shout at me, Mr. Man, you don't know what you are doing. Go back and check your code. One thing you should also note here is that this 5 here is telling the compiler ahead that we are limiting this array element to what? 5. So at compile times, it creates memory for what? For 5 elements. It needs to know ahead. Are you following? So as long as it is the same data type, you can create array for any type. As long as it is the same. That's not the condition there. Now, what I briefly jumped into earlier on, which is type conversion. Can also provide ability for you to change from one type to the other, as long as that type you are converting into can take the value of the previous one. When you are doing type conversion from a large type to a smaller type, you use try into. There's this particular core function or core enum known as what? Option. Are you following? Known as option. We have two majorly. We have result enum and we have option enum. So for results, it is either telling you this computation is correct or an error. For option, it's either telling you this thing has value or it is what? Null. Are you following? In this situation, we are trying to convert X, which is 255, into U16, right? We do not need trying to here. Why? Because U16 can take 255. The largest number of U16 is larger than 255. If it is the other way around, then we need try into. We'll see all of this in action when we get to Starkling. Intro traits. This is the opposite of trying to write. What must be explicit. Cairo doesn't do implicit conversion. Let me give you an example here. Let X equals to 35. Let Y equals to X try into now, what the error you are going to run into here is that X does not know what to actually convert. This trying to does not know what to convert the value of X into. Are you following? Because it's not explicit. What is X? What is Y? That is when it is going to know which of them is actually the one to convert to this. Let's say this one is U8. This one is U16. Have you seen the correction now here, right? It does not do implicit type conversion. You have to tell it from where should I convert and to where am I converting into. sharp. So functions, these are interesting parts of any programming language, because what makes a language both read and write is because there are functions that you can use to change the state of a particular program. Without function, you will only be able to read the states. Let us assume we have declared that block header equals to 100 million. What we'll only be able to do is to be able to still read what is block header equals to 100 million. But if we want to change that 100 million value, we need what? A function. So functions are declared using the function keyword here. Without the fn keyword, you are not declaring a function in Cairo. Parameters and return types must be explicitly typed. Unlike JavaScript and even TypeScript, where you can use any or none, in Cairo, it has to be explicit. What type are you expecting as a parameter? And what type are you returning as the return type? Look at this line. We said we have a parameter n, right? It is what? A type of U32. Can we do this? There's no way I can manipulate this. There's no way I can manipulate, because if I do this, it can return what is known as what? This can work. Let me show you. Anybody who remembers what it is going to return is sharp. This function has no return type and there's no error. Why? Because we are not returning anything, right? So when you have a function that is not returning anything, what type is that? A unit type. So when you are not returning anything, it doesn't matter. You do not need to have a return type. But when you are expecting a parameter, when you are expecting an argument, your parameter must what? Be typed. It's important. There is also support for generic parameters or generic traits. You will get to generic traits in the subsequent class. Generic trait just means that this is a type that any type can be type of. Let's say T, type T. Type T can be U56, it can be U8, it can be short string, it can be byte array, it can be boolean. Are you following? That is a generic type. We also have pure function and function that modifies states. This is actually explicit from the explanation. A pure function doesn't modify states. This addition on the white marker board is a pure function, because we are not reading anything from the states and we are not modifying the states. What we are only doing is what? Calculating, okay, this particular function too is a pure function. This is prime. There's no state to modify here. We are only running calculation to determine whether the argument supplied is a prime number. Are you following? So that's the difference between a pure and a pure function and a function that modifies states. There are if-else logic, just like every programming language, control flow, right? In every programming language, we have control flow, the if-else, the while loop, right? The switch. In Cairo too, there are control flow. If S, for example, look at this is prime. If n is less than or equals to 1, return false. We don't just want to do computation. We want to return early if the value is what? 1. If the value is what? Equals to 2. Return what? Return true. Because it's a short number. 2 is only divisible by 1 and itself, right? But if the value modulus 2 is equals to 0, 2, return what? It's not a prime number. Any number that is divisible by 2 isn't prime. Then now go on and do the computation. But while we are doing the computation, okay. Okay. I 0. Why you want to do the computation? We want to loop. So once we determine that I times I is equals to the number supplied, is greater than number supplied, break it. At that point, you don't want to now determine whether that number is what? Is a prime anymore. But once it's not equal to it, you learn about all these keywords subsequently. Break just may terminate the computation. Don't go ahead. We already know that this is not what we are looking for. N is number supplied. And if the number that is the multiplication of itself is now more than that particular number, it is no longer applicable. Go on and do the computation. If n modulus I is equal to 0, its prime is what? False. Then break. So what I'm just telling you here is just control flow. If S, worry, get there. So basically, a control flow allows you to modify or check for conditions in your computation. If S, Y, and then and loop. Early return with return keyword, trait implementation. Wait, we were ahead of the time. We've already explained all of these concepts. Unique memory model optimized for proving. Variable that store the memory slots, right? Memory is append only. Value cannot be modified once written. We've already explained all of this stuff earlier, right? So we have trait and implementation. So it is similar to interface in JavaScript, in TypeScript, especially. So they define shared behavior across types. So can anyone remind me, what did I say the second learning objective, third learning objective? The third learning objective. Karyosynthesis, right? And keywords. Have you learned about them now? So if you want to declare a variable that is reused all over the code, what keyword do we use? Const. A variable that will be reused all over the code. Can you declare a const variable inside the function? Yes. You can declare a const. Let's see. Hmm. Are you seeing that now? So as long as it is within this scope, if your function runs into more thousands of lines, you can always use the variable a anywhere. Are you following? It is possible, but most time, according to convention, it is used outside of a function. The only difference here is that you must annotate it. You don't have any other option, irrespective of whether it's in within the function or outside of it. So my variables in Cairo, they are what by design? Variables in Cairo, they are what by design? Immutable, meaning that you cannot just change them. If you need to change a variable, what do you do? You use the mute keyword. How many data types do we have? That the basic data types, not the complex one. We have integers, we have boolean, we have felt, we have what again? Byte arrays. So basically, this is the intro to Cairo syntaxes. There are still a lot to be learned, and that to be in the course of us, in the course of subsequent classes, because it's just the introduction to Cairo. You are going to write code, you are going to learn array, you are going to learn structs. These are complex types in subsequent classes. You are going to learn pattern matching and match expression. So our third learning objective, get familiar with Cairo syntaxes. Have we achieved that? You said no, right? Have we achieved that? So our third or the last learning objective is going to take a majority of our time. It's now actually practicalizing Cairo syntaxes, seeing in action the core concept of Cairo. And also, if you have not set up your local environment, it also require you to set up a local development environment. Have anyone heard of Starkling before? So what do we do in Starkling? Hmm? We need fast internet. It is show me. Yeah. For the purpose of this class, you are going to have an assignment. The assignment will be to actually bring Starkling into your local environment and solve all the puzzles, all of them, before your next class. He said, it is doable. Before we leave this class, we will almost be done with half of the problems there. Before we leave this class. So what we will be doing together on my screen, when you go back home or you still remain here, whichever one, you will be able to solve Starkling. When is the next class? No, tomorrow is Thursday. So go to Starkling. This is the code base on this is the code base on GitHub. copy this, solve the issues, follow the instruction here, Starklings CLI. Follow the instruction here to get ready and then start solving Starkling. So the first stage. This exercise does not do anything yet, but it still compiles. Cairo file getting run needs to have a main function. So this file is a valid Cairo file. Before we start solving, there are buttons that you need to be familiar with. If you want to confirm if your solution is correct, you click compile. If you are stuck, you click get int. Right? So for the first function, why is our program compiled? Without a main function, Cairo program, Cairo underline it, program, we never compile. Without a main function, Cairo smart contracts, we always what? We always compile. But a program will never compile without the main function. Oh, great. The submitted code compiles perfectly. Click next whenever you are ready to proceed. Is anyone navigating to the website?
Yeah.
Oh, it's not connecting. Maybe that's network. Yeah. Anyway, this is the original idea of this particular exercise. So we want to compile this particular stage. Will it compile? Why won't it compile? There is no main function, so we need to add main function, right? That solidifies our knowledge that without a main function, a Cairo program will never compile. It's not available. Oh, no, it was available earlier. Let's go to the next. Compile. Let's see. Compile. It's a valid code. Which data type has not been assigned? Oh. So this means that without the let keyword, a variable declaration is what? Without the let keyword, I like checking my own assumptions. Without the let keyword, a variable declaration is what? What if you use const? Yeah, you must use either of let or const to declare a variable. So something went wrong with your code, failed to compile. Error code is very important. So you know exactly where the problem is coming from. It is telling us on line 2, there is this x 5. It has an invalid left-hand side of assignment. Where is the left-hand side? This side, right? From there, you start to get a hint of what has gone wrong with your code. So now we go back and say, let's Are you following? Will this solve the problem? Another reason why you need the CLI version of Starkling is that it doesn't require internet to compile and move from stage to stage. So once it is installed on your local machine, you can easily move from stage to stage locally without internet. And by the next class, you have to submit the GitHub link to the repository where you solve Starkling. Great. Our code compiled. Okay, what is wrong with this code? Let me even compile for before I start asking, but the debugging. There's no assignment. There are gurus here. You guys have finished Starklings, right? And now you are telling me you cannot submit on Friday. Nah. It's just variable. What should we use? He said, what should we use? What value should we use? 9. What value should we use? 5. What value should we use? 0. Why should we use 0? I love people who can actually prevent their opinion. I love it. The way he said 0, he said it with conviction. But it doesn't matter, to be honest. Whatever value you assign to it, it doesn't matter. Because the base of it is just to compare the S to 10. So when we mentioned control flow earlier, we said if S, right? So if this value S is 10, it is going to print S is 10. But if the value is either lower or more than 10, it is going to print S is not 10. But the important thing is that you cannot leave a variable unassigned when you are writing Cairo. Once you declare a variable, you must assign a value to it. Are you following there? Are you following with me? Are you on Starkling currently? Are you sure? Okay, the internet will take our time. While it is compiling, ask questions, even ask ahead, anything relating to Cairo.
Okay, sir. Regarding this verification of proof. So let's assume I wrote a program, and I want someone to verify it. So do I need to copy that folder, that target folder, and send it to him?
Yes, they also need to set up a target folder because the compiler, the scab, is actually looking for the proof inside the target folder. You understand? It has been written that it only look for inside target folder to be able to verify that proof. So what you need to do, you don't need to send them all of that. They only need to create a folder named targets. You understand? And follow the naming convention of what you have on your end.
Then also, sir, what is
So what's the issue here? Assign the value. Okay, we are actually playing game. We will still play game. Whoever answers the most questions here have a gift equals to 0. While compiling, any other question? A Cairo program is actually written to be provable, meaning that once you write a Cairo program, it generates proof. You can generate proof from a Cairo program and send to somebody else to verify. The idea of zero knowledge is that you want to be able to tell somebody I have done something without telling them what you have done. I have done this calculation, I have added A and B together, but you don't want to tell them the specific number that you have added. So they will have zero knowledge about your environment. All they need to do is that they are not taking your assumption or they are not taking your words for it. They will verify that you have actually done that computation of addition, right? So what they will need to do is just the proof that you generated, which doesn't contain the value you inserted to do the computation. It does not. You understand? You send the proof to them, they run the proof through their own verifier, and if it is successful, there are only two results from proving: successful, not successful. Are you following? So a Cairo program is the only provable stuff. Why StarkNet smart contracts? StarkNet smart contract is provable, but it's basically you doing transactions, moving from one variable to the other. The essence of using ZK for StarkNet is what's known as scalability. If every validator needs to approve all transactions, like they need to do the computation again, the computation will send to the sharp, right? If every validator needs to do it again, it will take longer time. That's why Ethereum actually takes time to add. So the next task, what is wrong here? Who will solve this? You've not even seen the code. You've done Starklings. You've done Starklings already. Okay, we'll get you somewhere. Don't worry. So you see the condition here. Don't change this line. They know you want to do shadowing. If you do shadowing, it will work. Are you following? It will work, but they say don't do shadowing. You know what we want you to do. Just make it mutable. Okay, someone has something to say about. So what's the problem here? Line 4. We should use let. So by using let, what are we doing? Variable is simple. Why, apart outside of what we have learned from the code, why do you need variables? Store a value. Yes. What other reason? Computation. Perfect. What other reason? Store a value, computation. What other reason? Why can't we use var to declare a variable in Cairo? VAR. It is not part of the syntax. Correct. When you mutate a value, can you still access the previous value? Can you still access the previous value? When you mutate a value, let x equals to 5. Let mut x equals to 5. Then you said x equal to 10. Can you still access 5? I used, I illustrated it on the board, right? Compile. So what's going on here? This thing will never compile. No? How is it compiling? You need to specify type. How do you specify the type? Const. How do you annotate a type? I know you know how to do it when you are typing, but say it out. Colon. Then the type. If you not type a const variable declaration, what will happen? It what? It becomes, if you not type a variable, a const variable declaration, what will happen? If you don't type it. If you do not annotate a variable, a const variable declaration, what will happen? It will lead to an error. I realize that the word, if you do not type const variable declaration, sounds ambiguous. Because it could mean maybe you should be typing it out. So instead, annotate. If you do not annotate const variable declaration, it will lead to an error because the compiler will hold you. It will draw you back, say, okay, you know, they go and visit that const declaration. I need to know at compile time explicitly what type it is. One thing I love about this bootcamp is the fact that every time we have this bootcamp, it is like paying developers forward. Because a lot of the people in the last 2 cohorts contributed to our code base that went live a few weeks ago, a few days ago. And if when they invited me to come and teach, I felt like, no. We wouldn't have actually trained smart Cairo developers that wrote world-class code for our project that launched last week. A couple of the people in the last cohort actually contributed to the code base. And they did awesomely well. In fact, I have a bias as a maintainer of project on OnlyDocs. Once it is blocked out Web3 that trains you, I tend to give and assign issues to them a lot because you are tested and trusted. And I'm very sure if you do not even know what to do, you come to the community. There is someone that is tested and trusted that is going to help you. So we have moved to primitive types. Okay, people who have done it. Let's get started here. Finish this line. It's too simple now. What should we do here? Let this evening equals to this evening. Oh, I wanted to write evening. Good evening. let is equals to, why is it true? What if it is false? We have an estimate. We do not. The if statement, the body of the if statement will not run. If S is false, the body of the if statement will not run, right? So meaning that by default, when you see it's evening, which is a Boolean, right? It is telling you that if it is written like this, it is telling us that what? If it is what? If it is true. What do we want to write if it is not true? Exactly. Exclamation. Let's try to compile. So if you want to skip, for example, let me see implementation in one of the code. Look at this implementation on the screen. So if here is comparing duration, an argument supplied, right, to 0. If it is 0, return immediately. This is one of the places where you can use if without S. Somebody mentioned it must have an S body the other time. If you want to return on time, you want to check if something is something. If it is not, then we continue with the execution. Are you following? If duration is not 0, we will continue with this execution. If it is 0, we immediately return this value. You've never written Cairo code before, right? Has anyone written Starknet code before? Talk to all of you have started applying to only those issues. All of you have started applying to only those issues. Ahead of time, you've already started writing Cairo before learning it. Money is the biggest motivation. What I wanted to ask is, does this look intimidating to you? It looks intimidating. You wonder how they are working together. In fact, by the time you end this bootcamp, you feel like, oh, now this thing. Because maybe when God first created human being, maybe the people that are not familiar with that creation before will like, I wonder how it will be working. I wonder how it will be eating. What if he wants to urinate? They might not even know what urinate is itself, because the concept begins to make sense if you already know what it is. These are just like human body. They are components that are there until you need them. I'm not using my leg now because I don't need it. But it is there. It doesn't, just like my leg is there now, I do not need it. It is there. They have just functions that when you get to one part of the code, you need it. Do you understand? All right. This is where it gets interesting. These are simple stuff. What the? A short string is a string whose length is what? A short string length is what? 31. I will not be the teacher showing you. Short string are actually facts. They are not real string. So we have a short string here, which is cap C, right? It's alphabet, ref C. Whenever you see ref something, what is going on there? You said it's borrowing. Referencing the value, borrowing the value, they are the same thing. So here they said finish this line like the example. What's your favorite short string? What's your favorite short string? What are we doing here? We should annotate it. Mutate it. Okay. Mute. My what? What's my character? Okay. Your character equals to what's our favorite character? YA. Excellent. The following code is blah, blah, blah. Okay, can anyone explain what's going on here? What's going on here in this block of code? You said, can I remove it? The highlight? What is its alphabet? No, it isn't. Look at it here. It's a function that is expecting what? It's expecting an argument called char, right? But borrowed. And it's expecting it to be type of what? 252. And it's going to return bool. Now, when we call it here, the condition is that when we supply your character, which is what? A. When we supply it to your alphabetic, it compares if this is what? If it is A, what does it do? It continues. If it's less than or equals to, it returns what? Since our alphabet is not A, what happened here? We skip. And then move on to the next block. Are you following? So now, if it is true, remember, this is actually bool, right? If this is true, meaning that the character we sent matched what it's expecting inside its alphabet, we run print line. But if else, if it is not true, let's check again. If it is numeric, meaning our character, if it is numeric, we do what? If it's either not character or numeric, we do what? neither alphabetic or numeric. Okay, what are we doing here? What data type is this? So what data we should do on line 3? Destruct the tuple. So how do you destruct tuple? Normal bracket. This knowledge is from where? From Cairo that you have learned before now. Or from the Cairo that we started earlier. From the Cairo before now. So what should we name? So what is happening inside the brackets? Name, age equals to cat. So this is what we need to do. Are you sure? Yeah, I will not be waiting for compiler. If it doesn't compile, we'll go back. It will tell us. Now, this function requires you to modify the type of this function to prevent an overflow when summing big values. What is an overflow? When the value is bigger than the maximum, just put it anyway. The maximum number of a particular data type, when the value you are assigning to it is larger than that maximum number, you have what is known as overflow. So the maximum of U256, we are assigning it to data type U8. What happens there is what? An overflow. An underflow is the opposite of that. Let's say for U8 now, it is from 1 to what? 255. If we are assigning -1, will it take it? Because it is lower than what? It is lower than the lower band of that particular data type. 0 to 255 is a U8, right? -1 is lower than the lower band of that data type because it starts from what? 0. So we have an overflow or an underflow in that situation. Now, if you want to protect against overflow in this situation, what do we need to do? What should we convert? Basically, I'm supposed to even run the compile so that you see what the error is, right? Let's look at the code together. So this particular test, the first test, sum UH, right? We're passing 1 and 2 to the function, this particular function. And we are comparing the result, the output of it to what? To 3. If it is correct, this assumption what? Is correct, is successful. Otherwise, the test will fail. Will this particular test pass or not? This test is sending 1 and 2 to this function. So 1 is now x and 2 is y. And we're adding both of them together and returning it. This is called implicit return in Cairo, meaning that when you do not end a statement or an expression with semicolon, you are telling it what? Return this expression. Are you following? So now we are returning x and y. Here we sent 1 and 2. What does it return? 3. So comparing the output of this function with 3, will this assumption succeed or fail? It succeeds. Let's look at this particular one. Some big numbers. Big number here, the function signature is what? U8, U8. And it's supposed to return U8. But we are sending the maximum of U8 twice. When you have dots together, the value, is it going to be within the constraint of U8? It sees it, right? Is 5 times even U8? Without running the compile, we already know that this is going to fail. So first, we need to go back and say, we do not want to change this value, right? Instead, we could have changed it to something lower, but we do not want to change this value. We go back and change this to something bigger than U8. Because mentally, you already know that any number that is not U8 is larger than the maximum of U8. In this situation, let's use U16. U16. Should we still leave it as a return type of U8? Why shouldn't we? Because when we look at the test, we are passing 255 twice. The expected return type is what? Larger than U8. Let's go to U16. Now, here, what are we doing here? Change the data type to U16. With this modification, we expect this particular test to pass, right? Because 255 plus 255 is still within the constraint of U16. Now, let's test this. Convert to FET 1 U8 equals to 1. Where is our conversion to FET? Here. You said? Okay. Where is it? Convert. Okay, here. Convert FET. It is expected a type of U8, but the return type is what? Effect 252. 252 bits and 8 bits. Which one is larger? 252. So if you are converting from the smaller to the larger, what conversion keyword should you use? No, from the smaller to the larger, what conversion type should you use? Into. So meaning that we are going to do x into, right? Yeah. All right. So we want to convert back to U8. Try into. That is what x try into. Will this work? Oh, sharp people. Also, and why are we using dot unwrap? Huh? So that we can read the value, because trying to actually returns what? An option. The option looks like this. Some value or null. You said? None, sorry. Not none, none. Are you following? So we need to actually now go into if it contains a value, we need to get it from the sum. If it doesn't contain any value, we need it to panic. So mean that our program will fail immediately if that particular conversion doesn't contain any value, if it fails for whatever reason. This is supposed to pass. We'll keep testing and move on to the next. Do you understand what we did there? Type conversion, overflow. That should be all. Yeah. Return the value of x raised to power 3, right? S square 3 plus y minus 2. What should we do? Let's rest. You are guiding me. Equals to f raised to power. How do you do that? Power 3 plus y minus 2, right? Will this work? Actually, it will not work because it's not how exponentiation, right, works in Cairo. This is how it is expected to work. Let's say, we can do it directly. We can break down the calculation into two places. Directly, we say let's rest equals to x times x times x, right? Plus y minus 2. Are you following? We can break it to 2. Do this first. Init rest. Plus y minus 2. Right.
Is it possible to do x star 3?
No, it is not. This is the only way exponentiation works in Cairo.
So let me do like something like x raised by 12 or 15.
You keep I think you should. Let F around and find out. Plus y minus 2. Right? So the next one is the modulus. What is the takeaway from that last challenge? Yes. An arithmetic board mass, arithmetic calculation, mathematical calculations. Mathematics, arithmetic. So let's calculate the modulus of x and y. Fill me. What should we fill? Why? Why should we fill? Oh, wait.
Yes.
I've wiped all of you guys' memory. Nothing was there. All right, we'll change it to results. So let's do it. Let's results. Equals to x right? This is all right. What about this one? Results. Equals to modulus y. That's all. I'm closing it. Let results equals to x. Oh. It will work. Sometimes your brain will be busy and you'll be doing that and you'll be looking for the error. What is going on? Code is correct. Then, why am I using X instead of asterisk? So y, right? Which one? U size? U size is actually 64. Yeah, I think 64 bits. But basically, right, how they explain it is actually depending on the architecture of your system. You understand? U size depends on what architecture is your system. You know, we have U32-bit architecture and we have 64-bit architecture. So the U size depends on the architecture of your computer. So if your architecture is U32, U size is 32 bits. If it is 64, U size is what? 64 bits. So we have solved multiple. Once we get to this quiz, we will stop. Then you go and do the rest on your own. Do not use another function call. Do not use ChatGPT. I did not intend to say that, but somebody completed do not use for me. Okay. Do not look for solution until you try to solve the problem like 4 times. Do you know why? You'll be cheating yourself if you jump into looking for solution without attempting this problem first. You will get the code to compile, but does that mean you have learned something from that? So it is only when you know that this is not, the solution is not coming, then you start to look for Aha. Okay, what do we do here? They told us not to use another function call and not to add additional variable. So which of the number is the larger one? Is the bigger number. How do we do that? Okay, go back to look at the leftmost panel, or what do we call it? Side section. We are on what particular type?
A is bigger than B.
So what should I do here now? If A, B,
Return
return
A.
A.
But it's after the
And now you are telling me that I'm writing it now.
after if A is done with A, you're gonna have B, we put a curly bracket.
At all. So if A is greater than B, curly brackets,
So,
return A, right? But we can do it implicitly, right? A. And F, FB, right? Complete this function using if and or else block. Oh yeah, somebody should read this out. Fishy, fishy, fishy. Uh-huh. Uh-huh.
return O.
Uh-huh. Three fishes, two bars. All right. If fishes is what? Return S what? S if equals to okay. String literal, short string. What should we return? Bar. What happens if what should we return? Bars. For me. What's going on here? So what do we do? Okay. What will happen here? Why will it be error? What is syntax error here?
Okay, so return your number.
Why will it return my number? Somebody mentioned something now from that side. We are not doing what? No, not even display. No. We are not doing what? We are not returning anything. It could be like this and we just do return fetch 252. Right? So anytime somebody call me, they can say let number equals to call me. So once they run the computation, call me returns my number and that number is saved in what? In the number variable. The other one can be a unit function, but we need to use macro print line. if you don't want this to error out, because definitely it's going to return an error. And as well, we can just declare it without doing anything. Are you following? Number equals to, it will also compile. It will not return anything. We are not expecting it to return. It will work. But basically, what this implementation requires is what? A function called call me. Call me. Will this compile? Why won't it compile? You said no data type for. Okay. Where is the argument again? On what line? On line 5? Oh, it is true. So what data type should we use? U8. He said it should return. What if you want to return something? Return arrow. U8. Then after the print, you now write no. Oh. You now write now. Will this work? I love, oh, this compiler is taking too long. I love this situation. It will work, right? Why will it work? Why won't it work?
I think this first thing is enough.
No, this scenario now. Will it work? Why will it work? Because we are doing the right thing. Now let's see if we are doing the right thing. You know we are not doing the right thing. Who agree that we are not doing the right thing? Raise up your hand if you think we are not doing the right thing. No, if the situation is like this, right?
They are not storing the value is returning on line 2. The value is returning there.
Yeah, it is possible that you don't want the value.
That's fine.
Although the convention is that if you don't want the value, you use what is known as underscore. Are you following? But with this, will this still work? Why won't it work? Which one? No, it doesn't need. If you need to discard the return value of a function call, you use underscore. That means the compiler will let you go. But it will not work. There's a reason why it will not work. And I'm sure one of the key features of Cairo is what? Immutability is there, statically type is there, provable is there. What about, did we mention it? What about ownership and borrowing? We did not mention that. We didn't explain it deeply, right? And I said there will be scenarios where you understand, right? This is one of the scenarios. Because there's something called it will work. Do you know why it will work? And why it will not work? I will tell you a scenario why it will not work. Let us assume we have another function. New norm. It's whatever I want to do here. Let me even leave it as an empty this thing. Now do new noun pass now. Do you know why this will not work? Why?
Yes. Can be that verbs can be text. Like 96.
I just want to show you. It means that the value has been consumed on the previous line. So unless we're using ref, just like we did earlier on, it means we are borrowing. This one, we are already sending this value to what? To new norm. So this value is now invalid, this scope. Are you following? The value is now invalid in this scope, unless it's what? It is borrowed. This is a scenario where it is not going to work. It has been consumed by a function, so it is no longer valid in that scope. For the underscore means that if you just want to discard the returned value, you understand, from a function call, you don't need it. You understand? This particular function returns U8, right? This function returns U8, right? We do not need the U8 anywhere in the main function. We do not need the value returned. You understand? Once a function returns something, it must be stored in a variable. Are you following? So if we do not need that particular function at all, you discard it with underscore. That particular return value, you discard it with underscore. Is that understood?
You said what's a particular parameter or an element
depending on the function signature. If the function signature allows you to actually pass a borrowed value, you understand? From where you are sending the value, you will indicate that you are sending a borrowed value. Do you understand? But if the function only consumes the value, you can only send. Let me see if I can see that. Now look at this. Let's say, okay, no. We expecting the borrowed value, not the new value. If you want to be now as a parameter, we are sending a borrowed value of 3. We are not consuming it. Let me declare variable. Let's var equals to 3. Here we now say ref var. You understand? We can still use var in this scope. Are you following now? We can still use it in this scope. Because what we sent to call me is what? A borrowed value of val. Do you understand now? So, but if we are not expressly saying we want we cannot send this ref. Just the own value. And once this is done, bar no longer in the scope. Are you following? It has been sent, ownership transferred to call me. Mhm. It's as simple as
Forming in the main function is forming the main function is not taking an argument.
we are not passing argument to the call me function. So all we need to do is just to pass an argument. All right?
Yes, sir.
Do you know that Cairo allows you to do underscore in between figures instead of comma? So this is also 10 million. In fact, I didn't know how much I actually wrote until I used the underscore. So it makes your code look very clean because you cannot use comma. Okay, 10 million. Right? 10 million is within the range of 364. I'm looking at your sticker. Dream no small. Dream big. Dream big. Who wants to become a badass Cairo developer? Like you want to see some protocols and feel like I can do this thing, huh? Not the way they do for me. Let me see. Look at this code base, right? Even for me, it is intimidating. And the reason why it is intimidating is because I wasn't the one that conceptualized the product idea. So merely looking at the code, you'll be looking at where are they doing this tick? DeFi. DeFi is interesting. Where are they doing this tick calculation? You need to start looking throughout the code base because it's a very complex code base. You say it's obvious. But then to become a badass Cairo developer, you will need to be able to understand this code base without stopping. AI will not help you in situations. This is coming from someone who is very lazy. Because sometimes AI will tell you that, oh God, this context maybe they give me too deep. Context can be so deep that AI will not understand what to do. For example, you want to tell the AI to explain this code base. This code base is multiple thousands line of code. And now, you know, what do they call it? The token that you are sending as your prompt is even limited. So you are telling the AI to explain to you what this code base is doing. You will just this store is having a sale where if price is an even number, you get 10 Cairo bucks off. But if it's an odd number, it is 3 Cairo bucks off. Don't worry about the function bodies themselves. We are only interested in signature for now. If anything, there's a good way to pick ahead to future exercises. So what are we doing here? This code will compile. Why won't it compile? What is the problem with this code? If you look at what I read out now, if you heard what I read out now, I said, don't look at the function bodies. We are only interested in the function signature for now. We are not returning anything. Here, this says price. It has the return symbol, right? Signature, right? But nothing is being returned. U32. Why is it U32 and not a boolean? Because we are returning. What are we returning here? The price of -3 or -10. This is the end of our Starklings. This is the end of our Starklings, but here we need to do and pass this quiz. No hints. Do not change the test. So stop this problem. We already have the function signature. Let us just implement the function body. Look at the quiz. If Mary is buying apples, the price of an apple is calculated as follows. An apple costs 3 Cairo bucks. If Mary buys more than 40 apples, each apple costs 2 bucks. Write a function that calculates the price of an order of apples given the quantity bought. If she's buying less than 40, it is what? 3 bucks per apple. If she's buying more than 40, it is what? It is what? 2 bucks. 2 bucks. Okay, let's implement. No, no.
Brackets.
Okay. Let's use order. U8. Why are you choosing U8?
Based on the size of the inputs that from the test is not that big.
That's awesome. Deduction, right? We return U8. Then in the function body, if order is greater than 40,
then
curly brackets,
we multiply output by 2.
we multiply
Order
times 2.
and else we multiply by 2.
Else. I am laughing. Order multiply by 3. Now, in real life, right? This one just is simple, but still an example of real life, where you would have mapped out solution in your head without thinking of edge cases. Now, you are not programming your mind for what if order is 40. You are saying if it is less, if it is greater than 40, if it is not greater than 40, if it is greater or equals to 40. But they said if it is more.
Since it is more than that's 41. Less than 40. And some kids are like, this is like greater than 40, then and 40, then apply by the but it's from 0 and it's less than 40. I think that would be
As long as they not tell us that if it is 40, it is 2, right?
yes.
So if they tell us it is 40, we just do equals to or greater than 40. Oh, perfect. So thank you, guys. This will be the end of our Cairo class today. You have an assignment. You have an assignment. Go and complete the remaining parts of the Starklings. Pull the Starklings app locally to your local environment. Solve all the problems you solved. At least we have solved the first part together. Solve all the problems. By next class, submit the link to your GitHub repository where you solve the Starklings. Thank you.